All right, last chapter of our algebra book. So sad. Chapter 6. So we've been looking at linear equations and solving linear equations, graphing linear equations. We're going to now be looking at systems of linear equations. This is where linear equations really come into use in solving a lot of problems. Computers do this all the time. On a regular basis, every single day, we use computers with systems of linear equations. And so we're going to be looking at how to solve these systems of linear equations. We're going to look at 3 different ways. We're going to start with one today. So a system of linear equations looks like this on the bottom here. That's a system of linear equations. It's 2 linear equations, ax plus by equals c. 2 linear equations, and it's a system. What that means is there is one solution to both of these equations that's going to give us an x and a y that will work in this equation. It'll make it true. So if you plug in x and you plug in y, 2/5 times x minus y will equal 0. And at the exact same time, we will find that same x and y will work with 3x minus y equals 13. Where if you use the exact same x, the exact same y, 3 times x minus y will equal 13. And we're going to start by just looking at how this works and getting a little more comfortable with what this is. And then we'll look at some real-world situations where this is applied. But we're going to start off with just the basic, okay, how does this work? Getting a feel for this system of linear equations. We're going to start by just deciding. We're going to substitute in and we're going to decide, is it even a solution to the system of linear equations? So we're going to be given an answer, and we just have to decide, does it work or not? So let's plug it in. We're going to take this first equation here, 2/5 x minus y equals 0, and we have a solution that we're given, 5, 2. So I'm going to plug in x, and I'm going to plug in y, and let's see if it's even true. We're going to check it. So 2/5 times 2/5 times 5 is 2, and 2 minus 2 does equal 0. Check. I do need to see some work from this. I know some of you are already rolling your eyes and giving a very exhausted, oh, really? Yeah, you got to show some work. And so show me that it works, show me that it doesn't work. Don't just say yes or no. If it works for the first one, they're only halfway there. You got to show that it works for the other one too. So 3 times 5 minus 2 should equal 13. Let's see, 15 minus 2. Yep, 13 does in fact equal 13. Check, it works. And yes, you do need to show that check, that it works. Now, if the first one didn't work, there's no point checking the second one. If the blue one here did not work out, that 0 equals 0, it doesn't matter if the second one works or not. The only way this can be a solution is if it works for both of the 2 linear equations. So it's got to work for both. So it doesn't work for the first one, it's not going to work for the second one, or it doesn't matter if it works for the second one or not. Try this one on your own. Try this one on your own and see if it works. Again, that helpful hint. If the first one doesn't work, the second one doesn't either. I'm going to go through this one again just to do it as another example. So if I plug in my x and my y, for the first one, I get negative 2 plus 3 times 2 equals 4. Let's see, negative 2 plus 6 equals 4. Sure enough, 4 equals 4. Check. Good. Second one then, I go negative, the negative 2, the opposite of negative 2, opposite of x, plus 2 equals 2. Let's see, negative, that's like positive 2, plus 2 equals, 2. 4 does not equal 2, doesn't work. So no, this is not a solution to this system of linear equations. Try these 2 on your own. See if you can get them. Pause it, try it on your own. Decide yes or no, show some work. Assuming you tried it, I'm assuming you paused it. The first one, yes. The first one does in fact work, and yes, you need to show your answer or your work for that and make sure that it does. Second one, no, the second one does not work. And again, show your work on that. If you didn't get yes and no, make sure that you are watching the linked video. Moving on, finding that solution. So we were given those solutions to see if it works, just to check. Now let's actually find it. So 3 ways to do this. We're going to start with graphing. Graphing gives us a nice visual sense of what's going on. And so we can find the solution to the system of linear equations by graphing both of those equations. And you'll see that right here. The blue line is graphed and the red line is graphed. And the solution means that that point, xy, works for both lines. It works for both equations. And there's only one point. There's only one point in these linear graphs that is on both lines. This point right here at 2, 3. So the point 2, 3 is on the red line. If it's on the red line, that means that negative 2 plus 5 should equal 3. 2, 3. And sure enough, it does. Negative 2 plus 5 does, in fact, equal 3. And so it's on the red line. And it should work for the blue line as well. If this is x and that's y, it should work in the blue equation. 2 times 2 minus 1 should equal 3. Sure enough, it does. And so it works in both equations, and it's at that point where it's on both of the lines. It's where those two lines intersect. And so a solution to the system of linear equations can be found by graphing and seeing where they intersect. Let's try that. So we've got a system. We're going to find the solution to both of these equations at the exact same time by graphing them. So I'm going to graph that first one. I'll use blue for this one. Y equals x, and so my y-intercept is going to be 0. We just spent some time on graphing. The slope is 1, so rise of 1, run of 1. And this is where it's important to have a nice straight line, because if we want them to intersect, we have to make sure that it goes in a nice straight line. You can also just continue using the rise over run. You only need 2 points to make a line, but the more points you have, the more accurate your line is going to be. And so you can make that equation. There we go. Next one, negative 2x minus 3. So I'll do this one in red. So I'm going to graph y-intercept negative 3, a slope of negative 2x. So I go down 2 over 1, and I can't really continue that, but I can go the opposite way. So instead of going down 2 and to the right 1, I can go up 2 and to the left 1. Up 2 and to the left 1, up 2 and to the left 1. And if I graph that line, we've got our intersection point. So the intersection right there, the solution is negative 1, negative 1. Now to check your answer, you can plug it back in. For the first one here, x equals y, well, negative 1 equals negative 1, done, checked. For the second one, we'd have negative 1 equals negative 2 times negative 1 minus 3. 2 minus 3 equals negative 1. Yep, it works. So yes, it does in fact work for both. And that's how we graph and find that solution. Try this one on your own. Graph it, find the solution, check your answer, make sure it works. I'm assuming you graphed it, I'm assuming you found the answer, I'm assuming you checked it. The solution to this one is negative 2, 3. Again, if you did not get that solution, make sure you watch the linked video and see how it's done. Last one here, again, pause it, graph it, find the solution, check your answer. I'm assuming you graphed it, I'm assuming you tried it on your own, and so the solution to this one is 3 3/4, or 3.75, and negative 2 1/4, or negative 2.25. That was tricky. Those are weird numbers. Those are not nice graph numbers. And that's where we're going to move forward to. Graphing has its limitations. If it's not a nice whole number, it's hard to figure it out on a graph. And we're going to look at some more precise ways to finding that answer later. But go ahead, pause it, and watch the video if you didn't get anything anywhere close to that. If you said 3.5 and negative 2.5, yeah, you pretty much got it. But if you are way off from that, make sure you watch the linked video.